Series circuit retraction stroke. During retraction, the fluid goes this way. So if we want to calculate the force F2, that's gonna be F2 will be whatever force acting this way, and then the back pressure from the blank end. So the rod end force, which is P3 times the area of the piston area 2 minus piston rod area. So that's the force acting to this force is actually this minus the blank end force, which is this. So that's equation number 1. And if we want to calculate F1, similarly the rod end force, which is P2 times area of the piston 1 and then rod 1 minus the pressure on the blank side times the area of the piston 1. So that's equation number 2. Now before I add these two, I want to show you that same thing. For this synchronization, we need to have the flow that is coming out from this Q2 blank end will be equal to the cylinder rod end area. So that's going to be flow the rod end like that. So you can calculate these by the area of the piston of cylinder 2 times the velocity of retraction, and then this one same thing, area of the rod end now of piston 1, which is this, times the velocity of retraction. So we can write area P2 is equal to area P1 minus area R1. Now if we add these two, then because this area is equal to AP2, this and this will cancel out. So we can write F1 plus F2 is equal to P3 AP2 minus AR1 R2 minus P1 AP1. That I can say as equation number B. Now oftentimes this the flow returns to the vented reservoir where this thing is 0. Then we can write F1 plus F2 is equal to P3 AP2 minus AR2. I would like to call that B1 equation. Sorry about that, my skin goes black. So if we don't have any back pressure, then we use this B1 equation. If we have some back pressure like P1, is B equation. So that is SB1 for if there is no back pressure, 0 back pressure, and B for with back pressure. So that's the return stroke of the series circuit.